So thank you for joining us today. So today we're going to be looking at unit testing for WebSphere Message Broker code. WebSphere Message Broker is also known as IBM Integration Bus. We'll mainly be focusing on testing the ESQL that you write in a compute node. So what's behind this post? Why are we writing this post and developing this video? We have been doing work with various teams on how we can bring more contemporary approaches to WebSphere Message Broker or IIB development. We've been working on static code analysis with our MB Precise plugin. We have been working on capturing test coverage of end-to-end tests of broker code and workflows. The natural extension of this is to follow a shift-left approach. What we're looking at with a shift-left approach is move more testing closer to the developer. If you've been a software engineer for any amount of time, you would have come across unit testing before, whether it's JUnit for Java, NUnit for C# or DUnit for Delphi. To quote the internet, ideally a developer will be able to run unit tests so that all the code paths would be executed as a result of the testing. Unit testing is important because it is one of the earliest testing efforts performed on the code, and the earlier defects are detected, the easier they are to fix. And this is just a reference on Wikipedia around unit testing. So unit testing is the natural next step we are looking at to help improve quality. Acceptance tests can help verify what we're building makes sense to the client or customer. Unit tests give developers the tools to make sure that they test as many paths and combinations as possible. We probably all know this already, but knowing about the process and having the tools in place may not be the same thing, which brings us to this post. When WebSphere Message Broker generates ESQL code, that is the starting point for a computer filter node, it's not very testable. So this is an example of the business process, which essentially is just mapping a postcode name to a postcode. This code is difficult or impossible to test in isolation. What I mean is it's very difficult to execute this compute node or the ESQL from this compute node without having to process the entire flow. And processing the entire flow might have a lot more dependencies, such as input queues, service definitions, or access to the database. Also, the dependency on input and output route restricts how we create test conditions. So the first thing we need to look at is removing the direct dependencies on input and output route. Also, by being able to call this by itself, we can avoid any dependencies on other nodes that would be in the flow. This is not the only way we could have done it, but we chose to work with the environment as a way of keeping tests independent. This is the refactored code. What we've done here is we've taken the input route and created a reference to it. We've taken the output route and created an additional reference to it and passed this reference to a refactored version of the logic. The logic here has the same number of conditions and the same number of statements. So what we have now is a refactored version of the same code, but now we have a more flexibility in creating the input data related to the tests we're looking at to write. We will trigger the execution of this test case by sending a message to a test queue. And then reading the results. Here we can see we are writing to unit test 1 as an input, and sending the results to unit test 1 output. Inside the compute node, we can see that we're calling some logic, and at the moment the logic has no tests. So what we have now is an empty test case that currently has no tests. If we run our analysis, and then look at the analysis results for the project code we just analysed, we can see here that we have no test coverage. For our testable logic, we can see we have a number of entry points, but the red markers indicate that none of those entry points or conditions have been tested. So we're looking at test coverage of 0%. So what we're going to do now is introduce some test cases that will set up the input conditions and check the results and write those output those results to the output message. So we're going to return to our unit test, and what we're doing now is introducing a name test that tests the mapping for the suburb of Crace. We'll go into more detail exactly what the setup is, but just for the first example we'll just see that test 1 is being run. Now if we rebuild our bar file, copy our bar file to a new environment and run our build, we can see here we have some test results. We have one test, test 1, with the result of passed. So we'll just wait for our test to finish. Then we'll rerun our analysis. Now we go back into Sonar to look at our code. We can now see that we've gone from a coverage of 0% to a coverage, the coverage has moved to roughly around 15%. If we can then go back into our process logic, we can now see a green mark indicating the process has been executed. The orange indicates that one of the paths through this particular condition has been executed. The red indicates that this particular condition wasn't executed. And we can see here with a green line against Crace that the path to map Crace to a postcode has been executed. So we can see in our ESQL logic that contains our process, we have some lines covered and some lines not. So in the interest of being good developers and trying to get better code coverage, we can go back into our test case, add another test, rebuild our bar, and rerun our tests. We can see now that we have results from two tests. Test 1, which is passed, and test 2, which is also passed. So we have two successfully running unit tests. Now if we run our analysis again, and look at our project again, we can see that our test coverage has gone from roughly 15% to 22%. And we can see here there's an additional path through our code which has been tested, the one for Hawker. So we could keep doing this process iteratively so that we can keep looking at increasing our test coverage so all our 4 conditions here are tested. But I'll leave that for an exercise for later. I'll just go into a little bit more detail on how the tests are being created. So looking back at our test again, our first test 1 grace, we can see that we have made heavy use of ESQL to create the environment. So we're setting up the environment for test 1. We're creating our input and output areas to put the setup data in and verify and put the result data in. And then we're going on to create the structure that's going to contain the input suburb name, in this case Grace. This works, but it's quite cumbersome and requires a lot of code. Also, it's quite error prone, so we're likely to introduce issues in our testing with the way we write the test, which is going to lead to a longer cycle between when we develop code and when we can actually say it's been tested. If we go look at our second test, test 2 Hawker, this test creates a tree from the XML in a test. Although there's a few extra lines of setup, where we take the XML, convert it into a blob, and then encast the blob into the environment, we can create arbitrary large data sets or arbitrary large test data for this input quite easily, while the content of the actual input test data is quite easy to understand because it's pretty much just raw XML. So now we have our test cases that we can run and validate our logic. Ideally we'll be looking to make these part of our CI process, so that each and every time the build is run, we can verify that logic is still valid. So this also means that we can track our test coverage over time, and when our test coverage falls, we can look into address that by adding more tests. So for example, maybe days, weeks or months after the original development, a developer comes in and adds some new processing logic. So this time, the developer has rebuilt their bar, deployed the bar, and run some tests. Now they're happy because they look into the test results and they can see that they've still got 2 passing tests. Test 1 passes and test 2 passes. They then run the analysis. But this time they can see the test coverage has fallen. So they'll go into their logic that they've changed, and what they can see here is they've got a new condition which is not covered by unit tests. Now Sonar can be set up in different ways, including with threshold and by looking at the amount of coverage added or removed since the last change. So it wouldn't look at the overall percentage of coverage as you start from a low coverage base. It will only look at the newly increased or decreased coverage since the last analysis. So what you can do is set up rules that say we'll only allow test coverage to go up, not down. So we'll flag that as an error, which means we can now go and give immediate feedback back to our developer to indicate that they need to add some more tests for that new logic they've added. So with unit tests added, this means longer term we are less likely to introduce bugs, as unit tests can help prevent these by catching them early in development when we've introduced catch them early in development if we introduce a regression issue, which would be a test failing. We can also track test coverage for new logic, so we work out when we have a drift between logic and the tests. Again, so we can give feedback to our developers early and as part of their cycle. Good unit testing means that developers can refactor code more confidently, as unit tests should pick up any issues that they introduce. This can have some important cultural benefits for your teams. With good unit tests, developers are more likely to refactor code to make it better and cheaper to own. That brings us to the end of our presentation. I hope you have found this presentation useful. If you'd like to find out more, please feel free to contact us via our website www.bettercodingtools.com or email me at richard@bettercodingtools.com. Thanks again for taking time out of your day to join us, and enjoy the rest of your day. Thank you.